Hi everybody. In this video we will learn about chemical reactions. So this unit will be all about chemical reactions. We will talk about types of chemical reactions, balancing the chemical equations, predicting product, activity series, solubility rules, and dissociation, ionic and anionic equations. So the lecture about today is types of chemical reactions. So let's talk about what a chemical reaction is before we talk about types of chemical reactions. Definition: when atoms of one or more substances are rearranged or recombined to form a new substance. For example, we just did Lewis dot diagram in this previous unit. So you have hydrogen plus you have oxygen. Okay, and when these H2, basically it's H2 plus O2 to yield water. But what if you look at the chemistry inside, the two hydrogens are bonded, the two oxygens are bonded, and later we will have water. So if you remember this, this was done in unit 3. So what a chemical reaction is. Chemical reaction means breakdown of existing bonds and making some new bonds. So when atoms of one or more substances are rearranged, okay, so this is combining with the they're combining together instead of being individual. That's called rearrangement. How do we know that a chemical reaction has happened? If we see bubbles are being formed, let's say you have a beaker, and in the beaker you have the chemical A, and you put a chemical B, and as soon as you put the second chemical, you see that some bubbles are being formed. That means a gas is being formed. Okay, so if you see that, if you witness it, it means there has been a chemical reaction. If you see a color change, or if you see a smell change, odor means smell, so color or odor change means that it has been a chemical reaction. If you see a temperature change, we have done chemical reactions where we put things together and we feel a warm, we feel it cold, so there has been a temperature change. That means it is an evidence of a chemical reaction. Or if you mix the two clear liquids together, liquid A plus liquid B, you mix clear liquids together and you see formation of thick precipitates or solid, we call them precipitates or PPT. So if you see a formation of PPT, that is in evidence of a chemical reaction. So how do we represent that chemical reaction? We take the reactants and we yield some products. This sign is called yield sign. So after the yield sign, what you have is a product, and before you have is a reactant. The example I gave you earlier on was hydrogen and oxygen to yield water. So we will talk about word equations. There we will just simply write the letters, or we will talk about symbolic equations, the chemical equations. We call them skeleton equations, and we substitute the names with the chemical symbols, and not necessarily that equation is balanced. So in this video we will learn how to balance those equations. So chemical equation, it must show when we write a chemical equation, let's say hydrogen reacts with oxygen to yield water. Okay, so when we write this chemical equation, this equation must follow the law of conservation of mass. That means mass can neither be created nor destroyed. So whatever I put in here for the reactants, I must get on the other end, that means as a product. So if I have 2 grams of this and 6 grams of this, I must get 8 grams on the other side. Okay, or in other words, if I have 2 atoms of hydrogen, I must get 2 atoms of hydrogen. 2 atoms of oxygen means it should be 2 atoms of oxygen, which I see only 1. That means this equation is not balanced, so we need to balance it. Use chemical formulas, we use chemical symbols to identify things, and this number at the bottom, H2O, this number at the bottom is called subscript, and the subscript represents the number of atoms, and the number up in the front is called coefficient. So I'll discuss that in detail. So how can we balance the chemical equation? For balancing chemical equations, we cannot change the subscripts. we can only change coefficients. So I write the water again. H2 plus O2 gives you H2O. In this one, this is subscript, okay, and the number up in the front, which where right now it's no number, that means it's 1. This number is called coefficient. Okay, so right now the coefficient is 1 for all, and the subscript is 2, 2, and 2 and 1. So as I was saying, the goal is to balance the equation. You cannot say that I have 2 oxygens here, so I can just put the 2 and I'm done. Because when I change the subscript, I change the chemical nature of the compound. This H2O2 is the formula of hydrogen peroxide, the one that we buy from CVS. Okay, this is not water anymore. So changing the subscripts changes the nature of the chemical reaction. So that's why I cannot change the subscript. The only thing I can change is the coefficient. It means I can change this number. So let's see, I can change this number, the coefficient, to any number I like, as long as it's a whole number. Okay, H2 plus O2 is H2O. So I can change the number up in the front with any number. It has to be a whole number. And whatever the goal is, that total number of atoms on the reactant side is equal to the total number of atoms on the product side, which is the law of conservation of mass. So there are different steps to balance the equation. The first step is that you have to count the number of atoms. So let's say I have, for this equation, I have 2 atoms of hydrogen and I have 2 atoms of chlorine. On this side, I have 1 atom of hydrogen and 1 atom of chlorine. As I said, I can only change the number up in the front, which is the coefficient. So I have 2 hydrogens here, and here I have only 1. So I can only multiply. So this 1, what do I multiply the 1 with to get 2? Well, if I multiply by 2, okay, this 2 times 1 will give me 2. And the 2, this coefficient multiplies with everything in front of it. This 2 also multiplies with chlorine. So it gives you 2 hydrogens and it also gives you 2 chlorines. Okay, so now you see that I have equal number of atoms. I don't have to change all the numbers. Okay, so when I don't change any number, that means it's 1. But I don't have to write 1. And the coefficients have to be in the lowest possible, simplest possible ratio. Like I cannot balance this equation as 2, 2, and 4. Okay, if I end up doing it 2, 2, and 4, I can go back and simplify them. So the equation has to be balanced in the simplest ratio. Let's do some more examples. I have C6H12O6 plus O2 to yield CO2 plus H2O. So let's count the number of atoms. I have 6 carbon atoms, 12 hydrogen atoms, and total I have 6 plus 2. You know, I have to add them together. 8 oxygen atoms on this side. On the other side, I have 1 carbon atom, 2 hydrogen atoms, and 2 plus 1, 3 oxygen atoms. So as I said, the goal is to get equal number of atoms on both sides for each element. So let's choose the first element, carbon. The carbon, you have 6 on this side and 1 on this side. So my goal is to get 6 on that side as well. So I multiply this whole thing with the 6. That gives me 6 carbon. But this 6 also multiplies with oxygen. It gives me 12 oxygens right here. And I have 1. So now I have 13. Okay. The next thing I want to talk about is hydrogen. I have 12 here. So multiply this with 6. It gives me 12 hydrogens. But this also multiplies with oxygen to give me 6. So now I have 12 plus 6, 18 oxygens. Now I multiply this with 9, no, not 9, hold on a second, because I already have 6 right here. Okay, so out of 18, I have 6 here, so I need 12. If I multiply this with 6 to get 12, this 602 will give me 12 plus 6 will be 18. So this is how I have to balance equation. I know that you have learned this in middle school, so it is kind of a review for you. So, and we will do more practice in the class.